Fine. Terminating, I'll teach. Anna, I'll teach you later. Anna, terminating, non-terminating. Okay. Next one. Are you able to attend? Okay. Fine. Fine. Next, look here, students. In rational and irrational, rational and irrational numbers. First, all about rational. Yesterday, I told you anything related to rational, it should be written P divided by Q. That is numerator divided by denominator. Okay, it should have a numerator and a denominator. 7 is a rational number. Fine, anything in the form of P by Q. 7. Because if there is no denominator, what can we write, students? Can you write it as 1? If there is no denominator, you can write it as 1, right? You can take minus 5. This is a denominator. Minus 5 by 3 is a denominator. 0.5 is also rational number. You can represent. If you remove the decimal, how do I write it? 0 divided by 5. How many decimal numbers did we remove, students? After decimal, how many numbers do we have? 1. Yes, if there is one number, you have to divide by 10. So 0.5 is nothing but 5 divided by 10, 1 by 2. So whichever has numerator by denominator, that is a rational number. Okay, rational. For now, we'll just study this basic. Then we'll see the questions. We'll solve few questions now. So basically, we have four types of calculation, right? Addition, subtraction, multiplication, and division. Now, in addition, this is 10th. Okay, even for 9th, you'll have addition, subtraction. Look, arrange. If I tell you all to arrange minus 5 by 9, 7 by 12, minus 2 by 3, 11 by 18, in ascending order. Was this the question given? Andrea. Okay. Arrange this in ascending order, students. So, look, when it comes to rational number, even positive numbers, anything in the form of p by q, negative, decimal, all are known as rational numbers. All these are rational numbers. Okay, rational. Now, if I tell you minus 5, 7, minus 2, 11, how do you arrange in ascending order? What do you mean by ascending? Small to big. Which is the smallest number here? Which is the smallest number? First, you have to write, yes, negative number. According to integers, number line, this is 0, minus 1, minus 2, it goes on and you get minus 5. It goes on. Right hand side, you get 1, 2, 3, 4. This is ascending order. So minus 5 comes first. How do you arrange this? After minus 5, it has minus. Then we have 7 and 11. This was easy to arrange. The reason, did we have any denominators here? Do we have any denominators? No. If there is no denominator, it is easy to arrange, students. Alia, are you concentrating? If there is no denominator, it is easy to arrange, students. What if there is denominator? So the main concept here is you have to eliminate the denominator. You have to make them equal. So you need to take LCM. 9, 12, 3, 18. Start with the lowest number. You take a number which is common to all these four. What is the common number? 3 3s are 4, 1, 3 6 are 18. Next, anything common? Take LCM, students. LCM. 3 is common. 3 ones are next. 2. 2 is common. 2, 1, 1. Next. So what's the LCM, students? Multiply this. 3 3s are 9. 9 twos are 18. 18 twos are. LCM is equals to 36. Right? Next. Take the first question. LCM is equals to 36. How do you solve? 36, students. See, there are two ways. One, how many times 9 goes in 36? Then 5 into 4. You can do it like this. Or it's the same students. Just multiply. 7 and 12. How many times 36 goes? 3 times. Into 3. Next. Into 12 and into 12. Who's your teacher? Is it sir? Sir or ma'am? Ma'am. Okay. What about sir? Alia, do you have sir or ma'am? Even Anna? All are in same section or different section students? Tomorrow they're going to shop. No, at present. At present, same or different? Different class. Okay, next. 11 and 18 is given. 18 goes how many times, students? 18 goes 2 times. So when you multiply all this, you get minus 20 by 36. Next, you get 21 by 36. Minus 24 by 36. And 22 by 36. Now ignore the denominator. Ignore the denominator. Just look at the numerator. Which is the smallest value? Minus 24 or minus 20? Minus 24. Remember, in negative, students, in negative number, whichever is greater, that is the smallest number. So minus 24 is greater. This comes first. Don't write this. You have to write this value. What's the value representing minus 24? Minus 2 by 3. Next one. What's the value for this? Minus 5 by 9. Then which is smaller, 21 or 22? 21. 7 by 12. Then we have 11 by 18. Is it clear? You can even write less than symbol here. Yeah, you can put less than symbol. And along with this, they have also asked, find the difference. Find the difference between longest number and smallest number. Find the difference between largest number and smallest fraction. Largest number and smallest number. What do you mean by difference, students? Addition or subtraction? Difference meaning subtraction. Which is the largest number here? Which is the largest number? 11 by 18. So they've asked us to find the difference. Take 11 by 18 minus, was difference it is minus. Smallest number is minus 2 by 3, like this. You're supposed to write it like this. So 11 by 18, when you open the bracket, minus into minus is plus 2 by 3. Take LCM. Take LCM, complete this answer. You get an LCM, add. Wait, let me minimize screen. Alia, what did ma'am do today? Complete this today. Let me minimize it. Complete it. Only few topics will be easy. This chapter, the second. After that, it will be tough. What's the LCM for this? 8 threes are quick student. What's the LCM? 8 threes is 18. No, let just a minute. Which is the smallest number? Yeah, I've taken 8 students. It is 18. 3 and 18. Okay, if you take LCM, we'll get 18. 23 by 18 students. 23 by 18 is the answer. If you want to convert into decimal, you get a value. 15 by 18. Okay. Or you can convert into decimal. Do it later. Okay, convert into decimal. Anna, did you understand? Fine. See, concentrate from day one, students. From now, whatever homework I give, solve it. Okay, ninth is going to be tough, not like eighth. You'll have a lot of tough chapters in ninth. And only if you do well in ninth, you'll be able to understand 10th standard concept. Both are interlinked, ninth and 10th. Okay, so whatever you study for ninth, almost 30%, 30 to 40% concept will get repeated. Whatever you study in ninth, 40% of the concept will get repeated for 10th. Okay, so concentrate, only then you will understand the logic. These are some easy questions. Next one, we have LCM ascending order. Okay, it is a repeated question. I'll skip. Okay, now in difference between rational and irrational students. Rational and irrational. See, rational numbers are all the even numbers, odd numbers, anything in the form of P by Q. Okay, all these are rational numbers. And all the terminating numbers are also rational numbers, terminating. Terminating in the sense, if I divide 5, yesterday I gave an example. If I divide 5 by 4, 15 by 4. Okay, if we divide 15 by 4, you get 3.75. The calculation stops. This is known as terminating. The opposite of that is non-terminating. Non-terminating. This is irrational number. So in non-terminating, the example they give 0.100101 like this. This is non-terminating. If they give direct value like this is non-terminating. Okay, non-terminating number is irrational. Next, second one. If they give you 0.53, such types, all these numbers, and dots are mentioned, given here, dots. What does these dot indicate, students? What do they indicate? When do they put dots here? When do they give dots? Not recurring. Recurring is on top of the number. Yesterday we studied recurring and Andrea. See, recurring, where do you put dot on top, right? on top of the number. If it is next to the number, have you heard about what is this? Uncountable. It never ends, right? It never ends. Only then you put this kind of value. Now look here. If I take 6, 4 divided by 3 students, or 4 divided 20, 22 divided by 7. Can you see the number? It's not recurring. It goes on, right? It goes. Actually, this is also recurring. Let me take 22 divided by 13 divided by 3. Okay, all this. See, the number should be like, it shouldn't be recurring. The number shouldn't be recurring, but it should be continuous, students. Continuous. It goes on. This is known as non-terminating irrational numbers. Non-terminating irrational, and all the perfect square numbers. Next, when it comes to square concept, square. First, I'll explain few square and square roots. Then later we'll get back to this concept, rational and irrational. Look here, square and square root concept. Okay, what is 2 square? How much is 1 square, students? 1 square is 1. What's the square root of 1? It is 1. What is 2 square? All three are well. Unmute the answer. 4. What's the square root of 4? Just the opposite. Square root of 4 is 2. Yes. And 3 square is 9. And square root of 3, 9 is, how much is square root of 9? 3. You all should remember this concept. See, in simple linear equation, plus becomes minus, multiplication becomes division. You all are aware of all this. In the same way, square goes to the other side and becomes what, students? Square becomes root. Very good. Root becomes square. Remember that. Now look here. If I take this, 3 square is equals to 9. What happens to this root square if it goes to the other side? It becomes square root. What is square root of 9? What is square root of 9? 3. Both are interlinked, right? Both are interlinked. Square and square root. If I write 25 square, students, square root of 25, how much is square root of 25? Answer is 5. How do you get 5? See, if you factorize 25, you get 5 square. Remember 5 square. The value of this root, the root value is 1 by 2. In exponents, I'll teach all this. The value of root is 1 by 2. Therefore, 5 square remains as it is. I'll remove this root. I can write it as 1 by 2. I'll remove the root. I'll write it as 1 by 2. According to exponent law, 2 and 2 gets cancelled. That is how you get 5. Right? So today you'll have to memorize 1 to 20, students. Square root of 1 to 20. Square and square roots. Okay, this is square and square root concept. Next, even for cube, it's the same. Cube and cube root. Cube, cube root. So cube root of 1 cube is always the same. 1 cube is 1. Cube root of 1 is also 1. Next, 2 cube. How much is 2 cube, students? How many times you multiply 2? Yeah, you multiply 3 times. It becomes 8. What's the reverse of that? What is the cube root of 8? Cube root of 8 is 2. How much is 3 cube? 3 3s are 9, 9 3s are 27. And what is the cube root of 27? 3. In the same way, 4 cube. 4 cube is 64. Cube root of 64 is equals to 4. This is how in this is how you all have to study. You have to write up to 1 to 20. For square and square roots, write up to 1 to 20. You get it on net. For cube and cube roots, 1 to 10 is enough. 1 to 10. Now, all these values are rational numbers. We call all these as rational numbers. The reason is, look here, if I write root 16, students, square root of 16, how much is square root of 16? What is square root of 16? 4. Is 4, does 4 have denominator? Does 4 have denominator? No denominator. If there is no denominator, can I write it as 1? It's the same, right? So therefore, it has numerator by denominator. It is a rational number. Rational. But what about square root of 15? Is it a perfect square number, square root of 15? Tell me, students, is square root of 15 a perfect square number? No, it's not a perfect square. Look, square root of 15 lies in between 9 and 16. If I find the answer, if I check the answer for square root of 15, can you see here? It is continuous number, right? It is not repeating. The numbers are not repeating, but continuous. 3.8729. It doesn't end, students. Non-terminating number. It is a non-terminating number. Therefore, root 15 doesn't end. It is a non-terminating. It is non-terminating. Okay, it is non-terminating. Whichever number is non-terminating, it's an irrational number. Irrational. So the concept here is all the square roots and cube roots are rational numbers. Anything without perfect square is a cube irrational number. Irrational numbers. For example, cube root of 25. Check cube root of 25. Is it a perfect cube, students? Is this a perfect cube? Do we have here? Do we have 25? No, right? Alia, did you understand? What about Anna? Is it clear? Okay. Whichever doesn't fall in this cube root category, this we call it as irrational number, students. Irrational. This is irrational. Okay, rational and irrational. That's it. Now if I take cube root of 40, this is square root of 40. It's not a perfect square number. What is the number we have? Before square root of 40, what's the perfect square we have? All of you respond, students. What is 6 square? 6 square is? Okay, square root of 36 is 6. Square root of 49 is 7 and 6. So 40 lies in between these two, right? 6 and 7. 40 lies in between 6 and 7. So if you check the answer, look here. If I take 36 square root, it is giving 6. It gives us 6. If I take square root of 49, it gives us 7. These are called perfect numbers. Once you find the answer, it should have a rounded value like this. But if I take square root of 40, students, 40. See, the number is continuous. It doesn't end. In reality, it goes on. If calculator, actually in calculator, they've showed only this one. If you start calculating this root 40, there is a separate division, long division method. If you start calculating, the numbers will be continuous. It doesn't end. Therefore, these two are terminating. It ends. Terminating values. Therefore, that is a rational number. This is non-terminating. Non-terminating, therefore irrational numbers. Irrational. Is the concept clear, students? All of you understood what is rational and irrational? Along with this, there are two special types of numbers. Apart from this, everything is rational. Remember, everything is rational number. You take, see, if they give question like this, 0.56, 0.563 dash, which is rational and which is irrational here? Which one ends? Which calculation has ended? Tell me, for the first one, does it have any dots here? Continuous dots? No. It is ended, students. There is no calculation after 3. After 3, there is no calculation. This is a rational number. It is a decimal, it comes under rational. But look at this. This indicates that there is no stop. It goes on. The numbers are continuous. Irrational number. So remember, any number which comes with dots, any decimal number which comes with dots, it is an irrational number. Okay, in the same way, if I take root 4, rational or irrational? What is root 4? Answer for root 4. 2. What kind of number is 2? Do we have any value after 2? Is it stopped? Right? If it's stopped, it is terminating. Terminating comes under which one? It's a terminating number. Terminating comes under rational. If I write root 2, is root 2 a perfect square? Do you all think root 2 is a perfect square? No. Look at the value. Does it end? It doesn't end. You get 1.412, 1.4142. I can't write all the numbers, so I'll just give dots like this. So this is non-terminating. Meaning of non-terminating is never ending. Terminating meaning is end. It's come to an end. So this is non-terminating. Whichever comes under non-terminating, we call irrational numbers. So root 2 is irrational, 0.563 dash dot dot dot, these are irrational. Okay, then along with this, you have two special values, special numbers, pi and 22 by 7. See, 22 by 7 students. 22 by 7. We don't need to check whether it is terminating or non-terminating. That is not the question here. We don't need to check whether it is terminating or non-terminating. Does it have numerator by denominator? Isn't it represented in the form of p by q? One numerator and one denominator? All of you will respond. Then it is a rational number. 22 by 7. Remember, 22 by 7 is a rational number. Then there's a number called pi, students. Pi. In geometry, we learn this for circles. Okay, pi is a constant. Remember, pi is irrational. Irrational number. Pi is irrational. I'll give you a trick to remember this irrational. Can you see this r? Two r's given. This diagram, doesn't it represent like similar to this? All of you will respond. It's kind of similar to this. Remember pi. They'll definitely ask you all one question related to pi. So pi is an irrational number. Okay, pi is irrational. What are the other questions they did, Andrea? Sending on. They didn't teach all this rational, irrational. Okay. I'll give you all the notes, students. Just make a note, because if teachers, I don't know whether you all will understand or not, when they teach, take rational and irrational. Rational numbers, irrational numbers. Okay, tell me what are rational numbers? Anything which is written in the form of p by q. That is, which has numerator and denominator. Okay, 17 is a rational number. 5 divided by 7 is a rational number. So we are not talking about terminating or non-terminating, only rational, irrational. 5 by 7, it has a numerator and a denominator, rational number. See, 17 is a rational number. The reason, if it doesn't have denominator, you can take it as 1. 0.5 is a rational number, because it is stopped, terminating. After 0.1, we don't have any value. It is a rational number. You can write 0.1 as 5 divided by 10. All perfect square numbers are rational, perfect square. Root 4 is a rational, root 9. All cube root values, cube root of 8, cube root of 64. Perfect square numbers and perfect cube numbers. When it comes to irrational, anything which is not The number which is continuous, for example, 0. They'll directly give you like this, students, 0.560 and dots, 0.5601 and dots like this. This is irrational. So the opposite of perfect square are non-perfect cube numbers. Root 3 is irrational. Root 5 is irrational. Root 15 is irrational. The opposite of perfect cube number is non-perfect cube numbers. Those are cube root of 9, cube root of 5, cube root of 60. All these are irrational numbers. Make a note. All of you will make a note. Write it. What about 22 by 7? And what is pi, students? Pi and 22 by 7. 22 by 7 is what? It has a numerator and denominator. Yes, it is a rational number. Pi is irrational. That's it. Complete this. We'll solve few questions based on this. And one more thing, students. All negative values are also irrational. See here. Negative numbers. Minus 17 by 1 is a rational number. Remember. Minus root 4 is also a rational number. It doesn't matter whether it is negative, positive or negative. Here. Minus 0.5601 is also irrational. Minus root 3 is also irrational. Minus cube root of 5 is also irrational. Okay, so negative and positive doesn't matter. And one more thing, if it is recurring, it is also a rational number, students. Recurring numbers are rational. For example, 0.56 dash. If they give a dash on top, it is a recurring number. Remember, it's a recurring rational number. We call it as recurring or repeating. Different names are given. That's it. Okay. Any dash on top, or they might sometimes write a point, 0.26 point on top. Even this is known as recurring. So don't get confused. There is a difference between 0.26 if they write it like this. Yes, Alia. Yeah, you can leave. Alia, every day 10 or 15 minutes early you can leave. Okay. Yeah, you can leave. Anna done. Anna and Andrea completed. Okay. I'll tell you what kind of questions they'll ask students based on this. Here, the question which they have asked is the negative of an irrational. What will be the answer? What is the negative of irrational? Will it be a rational or irrational number? The negative number of an irrational. See, what do you mean by negative of an irrational number? Tell me any one irrational number. Any irrational number, students. Non-perfect square or non-perfect cube. What is it? Okay, let me take pi. Instead of pi, can I take root 3? Root 3 is irrational, right? What is the negative of root 3? Negative meaning is minus. See, it doesn't make any difference. It is still a irrational number. Look here, minus square root of 3. If I multiply by minus, students, multiply by, okay, you will still get a minus value. See, if you take negative value, minus root 3, minus root 3, minus will remain as it is. And for root 3, you get different values like this. 1.732, it is still a negative value. So minus the negative of an irrational number minus root 3 is still an irrational number. The answer is irrational. They'll give you four options. Option A, irrational. Option B, rational number. They'll give it as rational. Option C, whole number. Like this. Whole number starts from 0. It is not a whole number. Whole number will never be negative, students. Wrong. Whole number is not negative. Rational and irrational. Whenever this root 3 is irrational, even minus root 3 also will be irrational. So option A is the answer. Is it clear? Both of you understood? Next one. They'll give us any question which has irrational, student. That is the irrational number. Now, square root of 2. I'll teach you a few square root concepts now. Square root of 2 multiplied by square root of 3. Next, square root of 2, 4 divided by square root of 2. Next, square root of 4 plus square root of 2. Square root of 4 minus square root of 2, students. Look here. Only for multiplication and division. Remember, both of you, only for multiplication and division, you can take the squares common, students. You can take the root common. You can multiply 2 into 3. So what's the answer? 2 threes are root 6. Only for multiplication and division. 4 divided by 2. How much is 4 divided by 2? How much is 4 divided by 2, students? 2, right? So what's the answer? Root 2. Remember this, only for multiplication and division, whenever root is given, you can add and, multiply and divide. But for addition, subtraction, you can't do that. You can't write 4 plus 2 root 6, wrong. You can't write 4 minus 2, that is root 2, even this is wrong. Okay, we use a concept called like terms and unlike terms. When root value is given, we use like term and unlike term. So therefore, you can't add or subtract this. The answer remains the same. If it was root 4 plus 2 root 4. Now you can add them. Is the root value same? Are the root value same, students? Root value same. What is the coefficient of 4? Before 4, what do we have? 2. And before this 4, what do we have? 1. You can add them. You can add 1 plus 2 into root 4 will be common. So the answer is 3 root 4. You can add and you can subtract if it was like this. 2 root 4, 3 root 4, students. 3 root 4 minus 2 root 4. If the root values are same, root 4 and root 4 are like terms. Okay. In algebra, did you all study like terms and unlike terms last year? In 7th also they were taught you like terms and unlike terms. That is basically like this. Look here. 2x plus 3x. They are like terms, students. X and x are like terms. 2 plus 3, 5x. In the same way, whenever like terms are given, root 4 and root 4, you can take common. 3 minus 2, just subtract. 3 minus 2 is 1 root 4. And 1 root 4 is nothing but root 4 value is 2. The answer is 2. So remember this, you can just add and multiply and divide. Even if the roots are not like terms, you can multiply and divide, but you can't subtract and add them. You can just multiply and divide. Just make a note, we'll do 1 or 2 questions and we'll continue tomorrow. Is this clear? Anna, did you understand? Any doubts? Andrea, Anna? Okay, complete this, students. Just write these two. Only for multiplication, division. For addition, subtraction, it remains as it is. Answer is the same. You can't add or subtract. Okay, related to this topic, we'll continue tomorrow. Before that, bracket rule, students. How do you multiply this when there are two numbers? Yes, both of you will answer, Anna and Andrea. Multiply A into B is how much? You multiply the first one. It is AB plus AC. What about this one? AB plus into minus is minus AC. Okay, AB minus AC. If I write like this, 2A plus 3B. What's the answer, students? 2 into 2 is 4A plus 6B. If I multiply a square number, fine, that I'll explain tomorrow. It's a lengthy concept. We'll do it tomorrow. So today rational numbers addition was done. I told you what's the difference between rational number, irrational number. Then square and square roots. Square and square roots addition. Okay, we'll do one question based on this. We'll end the class. Now look here, students. If it is like term, you can multiply. What is root 2 into root 2? You can multiply, right? You can take root common. 2 2s are 4. What is root 4? 2. So remember this, whenever you're multiplying same numbers, students, same numbers, root will get cancelled. It is the value itself, 2. What is root 3 into root 3? Same numbers. No, not 9. Root 3 into root 3. Direct answer is 3. And how do you solve? 3 3s are 9. What is the square root of 9? 3. Remember the direct values. Root 5 into root 5. What's the direct answer? It is 5. But if it is root 5 into root 6, numbers are different. What's the answer? 5 6 are root 30. Root 30 is the answer. And still you have to factorize this root 3, students. I'll explain that tomorrow. Entire root concepts I'll explain tomorrow. All the calculation part. How to simplify and all those things. For today we'll end only till here. Okay, we'll complete it till here. And what about the notes? I will written it.